Looks like it's working okay in the browser I've got. Welcome along to this talk called Adventures in Container Vulnerability Scanning. The goal of this talk is really, I think container vulnerability scanning is seen as a kind of a foundational practice with most, Kubernetes or container security setups. But it can be seen as a bit of a black box. In a lot of cases, I don't think that people can kind of, you run the scanning tool and you get out a list of CVEs and a list of severities, and you're just kind of asked to, address them. And the goal of this talk really is to try and demystify that a little bit, to talk a bit about how CVEs work, to talk a little bit about how CVSS scoring works, and also to talk a little bit about container security and container security vulnerability scanning, just and how, some of the things you need to know about or could think about while you're doing that. So what we'll do is I will get started. Let me just turn that off. And before I get started, the very quick about me. So I have been in, my background is in information and IT security. Previously, for about the last 10 years or so, I was a pen tester, security consultant, reviewing the configuration and security of a lot of products. And I had a lot of experiences with vulnerability scanning tools, which is basically the reason why I'm doing this talk. A lot of my time in the last 5 years has been with containers, so Docker, Kubernetes, that kind of thing. And I'm now a cloud native security advocate for Aqua, which basically means my job is to try and help improve the cloud native container security ecosystem, doing things like this talk. As part of that, I'm a CIS benchmark author for Docker and Kubernetes. So those are good configuration security standards you can use if you're looking at trying to secure those environments. I'm also a member of Kubernetes SIG Security and the only unofficial Kubernetes SIG, I think, to have keynoted KubeCon, which is SIG Honk. And that's just a group of people who kind of enjoy hacking around and looking at the security of Kubernetes. One of the good things about working everything with cloud native and in the cloud is you can pretty much live wherever you want. So I stay here. This is Loch Goil Head in the Scottish Highlands. And as you can see, it's very nice when it's not raining. But if you've ever been to the Scottish Highlands, you know that it unfortunately is usually raining. So anyway, let's get on with the talk. One of the first things I want to quickly discuss was where vulnerability scanning came from. What are the origins of vulnerability scanning? How did it get started? And the story for vulnerability scanning really starts in the late 1990s or mid 1990s. With this kind of this is the logo for one of the very first vulnerability scanning tools there was, which was called Satan. The claim to fame for this logo is that it was done as an original drawing by Neil Gaiman, who you may know from Sandman or Good Omens or things like that. And this was a tool that scanned across the network, looking for security vulnerabilities that could be exploited. And it was followed on in the kind of later on into the 90s by a tool called Saint. Saint was also a network vulnerability scanner. So this also worked similarly. It scanned across the network, looking for exploitable vulnerabilities and things, misconfigurations, things like that. Maybe Telnet, SMTP, that kind of thing. It was in 98. Nessus came along. Now Nessus is still around today and still going strong. It started as an open source project, another network vulnerability scanner. And one of the problems that all these tools had in the early days of their existence was, how do you uniquely identify a vulnerability? How do you canonically say that if I'm running multiple different scanners that I've found the same thing? You need some kind of common naming. This became even more apparent when scanners started logging in. So they do credential checks where they would log into a host and they would scan the installed versions of software and look for known vulnerabilities in those versions, which is actually pretty similar to what container vulnerability scanning does now. On the Microsoft side, there was a thing called MBSA, Microsoft Baseline Security Analyzer, and it did a similar idea. It would log in and check for installed software and see things that were out of date. But it had this problem as well, which is if you're running multiple scanners, how do you make sure that what you found from one is the same as what you found from another? You need a common naming format or a common numbering format. And that's where CVE comes in. CVE, Common Vulnerability Enumeration, is actually Common Vulnerability Exposure, is a common naming format for vulnerabilities, which started in the late 90s, 1999, with MITRE, who are a US organization, kind of quasi-governmental, And they started by giving out these numbers. And you'll have seen them when you do vulnerability scanning. You'll see CVE, and then a year, and then a number. Initially, they would hand out all of these numbers, but then as time went by, they wanted to devolve that responsibility, so it wasn't just them handing out the numbers. So they have a group of now what's called CNAs, which is CVE Numbering Authority. There's a couple of different types of CVE Numbering Authority. You get things where vendors, so for example, IBM is a CNA, and they are a CNA for their products. So if the CVE needs to be raised in an IBM product, the organization responsible are IBM themselves. They actually issue their own CVEs. Another one which you might be more likely to come across is GitHub. So GitHub are a CNA, and that means that if you are using the GitHub Security Advisory feature, you can get your CVE number from GitHub directly without having to go to MITRE or anyone else. And it actually it's a great improvement on some of the older processes where it was centralized and MITRE had some problems like keeping up and actually issuing all of these CVEs. So that's it. That sounds like a great idea, right? We've got this numbering, all the vulnerabilities are numbered, and we all know what the numbers are. Fantastic. But there are some things to be aware of. The first is, this is a potential problem, is that not all vendors like having CVEs raised against their products. And if a vendor decides that they don't want one, especially if they're the CNA for their own products, it's pretty difficult to get one issued. It is possible. MITRE can act as the CVE issuer of last resort, but a lot of security researchers are not going to go to that end. This page here is actually an official section from an IBM document for their mainframe line of products. And IBM's official policy for their mainframes is that they do not issue CVEs for mainframes. The information about what security vulnerabilities there are in their mainframe platform is kept confidential and only provided to paying customers. So that means that one thing to watch out for when doing things like vulnerability scanning is not everything will get a CVE because sometimes the vendor doesn't want one to be issued. And if you think, some people may say, oh, mainframes are very secure, they have no CVEs. Well, that's because IBM don't agree to issue them. Another problem which might come a little bit closer to home is libraries as well might not always want to issue CVEs. This one here, CVE 2019-11253, this is a Kubernetes, or was found in the Kubernetes project. It's in the API server, and it is a YAML denial of service. The basics of the vulnerability was that if you gave it the API server a YAML document that was specially crafted to have recursive entries, when the API server tried to parse the recursive entries and expanded them, it would chew a lot of resources on that API server and cause it to crash. And I was involved in helping with the disclosure process for this vulnerability. Now, obviously, the Kubernetes API server doesn't implement its own YAML parser. What it does is use a library. It uses GoYAML. And when we were discussing this vulnerability and this issue, we discussed it with the library owner. And the library owner's perspective on this was that this wasn't a vulnerability in their code because they were behaving per the YAML specification. The YAML specification essentially is ambiguous on how you exactly handle recursive entries to avoid denial of service. So they didn't want a CVE raised against their project. But this led to a rather unusual situation, because if I'm a vulnerability scanning tool and I flag a version of GoYAML that's old and outdated and doesn't have the fix, what CVE do I assign to that vulnerability? The answer has been, and I've seen tools do this, they'll use the Kubernetes one. So if you use GoYAML, even if your code base has nothing to do with Kubernetes, you might find a Kubernetes CVE in your vulnerability report because there is no one for the library at hand. So that's another thing to be aware of with vulnerability scanning, is the fact that you won't always get a CVE for every vulnerability because of things like this. So we've got this unique identifier, which is useful. It's not perfect, and it's definitely well worth being aware of why it's not perfect. But we don't know how severe these vulnerabilities are, because when you're going to prioritize your issues, you need to know how bad it is. Do I need to put this to stop production and get this patched now? Or do I need to just put it on the backlog? And the next time we're upgrading this dependency, what I do is I say, okay, we'll probably upgrade this this dependency next time we're doing patching or whatever else. And that's where CVSS scoring comes in. So Common Vulnerability Scoring System. The idea here is that you have a score between 0 and 10, with 0 being, it doesn't really matter, and 10 being, this is incredibly critical, you're going to be compromised if you are attacked. And that kind of dictates how severe your vulnerability is. Now, one of the challenges with the CVSS scoring system, and how essentially I'm going to walk through this a little bit, is it can make you think that there's a kind of scientific, repeatable process behind that, because it's got this quite precise sounding number. It'll be 4.3 or 9.8. It sounds fairly precise, right? But let's look a little bit about how these things work. This is what's called the CVSS base metric, and this is what the scores out of vulnerability scanners you will see. There are other things you can do to kind of fine tune them, but when you get something from a scanning tool, it will almost always be this base metric. And the base metric is achieved by assessing each one of these categories. So attack vector, attack complexity, so a bit about how exploitable it is, and then a bit about what the impact of this being exploited would be. Now, the problem with this comes because these are subjective, essentially, I would suggest. They're subjective in a lot of cases, and subjective based on the person doing the assessment. So does that analyst understand exactly how this software is being used in every case? Well, they can't. All they can do is take a generic look at it and go, generically, problems of this kind in this kind of library are likely to cause these kinds of issues, and I will assess it based on that. Sometimes it will be the project themselves assessing. They may have a better idea. Sometimes it might be a security analyst in some security company doing the assessment, and they're not even attached to the project. So there are also, I think, some challenges around these scores, and one of the reasons I think you should be mindful when you're doing vulnerability scanning that the scores might not always be super accurate. To give you a little bit more detail, this is how attack complexity is assessed. What it is basically just high or low. So the analyst looks at the vulnerability, and then for the complexity, now they've not done a bad job here of trying to lay out the criteria, but I think you can see why these are subjective. Because the analyst in question doesn't necessarily have all the details to assess. Will it always be no specialized conditions existing, or will it sometimes be? It probably depends on the configuration. It probably depends on how the software works in a given circumstance. So let's talk about some specific examples. First thing is you can get some unusual scoring. So these are 3 vulnerabilities that I took from Tenable's vulnerability database. I'm not particularly picking on Tenable, but they have a good large vulnerability database, which is quite heavily used, so it's a useful example. The first vulnerability is the use of a self-signed certificate. So in this case, you're using TLS, you're using an up-to-date version of TLS, but the certificate you're using is not signed by a certificate authority. The risk there might be that someone who can successfully sit on the network between you and the server can try and man-in-the-middle attack you. And this would allow them to intercept your communications and pretend to be the server. So it's not an ideal configuration, and you will get a vulnerability for that if you run a scanner against it. The second one is the use of SSL v2 or 3. Now these are old versions of the SSL protocol. They are vulnerable and they absolutely have security weaknesses, and I would not recommend using them. But in reality, exploiting them is quite difficult. It's quite a high-end attack. You need to be man in the middle again. You can't just passively sniff traffic, and you need to actually, mess around and intercept and do things. Not trivial. The last one is totally unencrypted telnet port. So there is no attempt at encrypting the traffic, and there is no attempt at authenticating the server that you're connecting to past just its IP address. Now, if you were rating these 3 issues, and you were going to say which of these has the highest CVSS score, which would you think is going to have the highest? To me, telnet, right? Because there's no encryption. I'm not even trying to encrypt it, let alone, almost getting it right apart from one thing. But if you run Nessus on, and a host has these 3 issues, the telnet will come back as 5.8, the self-signed certificate as 6.4, and the SSL v2 v3 as 7.1. So this is where I'm starting to say these things are subjective, and that is hopefully an example of it, right? What you might think intuitively isn't necessarily what's going to come out of scanning tools. To give it a slightly more close to home again example of this, this is an example again from Kubernetes. CVE 2018-1002105 was one of the very first CVEs that was publicly disclosed in Kubernetes. And this was a vulnerability in the aggregated API server, Kubernetes aggregated API server, which is a feature you may not use that often. The idea is that you can sit another service behind the API server. So something like the metrics server is a very good example. And if you're using that configuration, this vulnerability could have allowed an unauthenticated attacker to essentially masquerade as the API server when talking to the metrics server, allowing for the metrics server to be compromised. The thing is, that only exists as a vulnerability, that path, if you are using the aggregated API server and have something sitting behind it. This CVE got rated as 9.8 for every Kubernetes distribution, even though the majority of Kubernetes distributions don't use that feature out of the box. They have it configured usually, but there's not necessarily anything behind it to be compromised. So this is another problem with CVSS scoring, is which configuration do you assess? And if you're assessing Kubernetes vulnerabilities, that's incredibly difficult. There are 130 different products and distributions of Kubernetes, so your CVSS scoring by its nature is probably only going to be able to take account of one of them. And a lot of the time, it will just come down to the people who are doing that scoring mechanism and their own personal experience. In this case, I think it might have been someone at Red Hat who scored that because that score applies correctly to OpenShift, but doesn't necessarily apply to other distributions. So that's another problem with scoring. And the last one, this is one I just came across fairly recently. Whose rating do you use? Because different bodies will rate the same vulnerability differently, which again explains that CVSS scores are going to be subjective, because otherwise you would get the same rating if it was objective, but if it's subjective, if it's a matter of opinion, then different people will have different opinions. This one is CVE 2021-30465. This is a vulnerability in runC. It's actually quite an interesting vulnerability, and essentially it's a race condition that lets you get privileged access to the underlying host. And if you're interested in hearing more about this, there's actually a talk at KubeCon that I'm helping with where we talk quite a lot about this vulnerability. But that's besides the point for this talk. For this talk, it's just something I noticed when researching this, which was that which was the project themselves on their GitHub advisory, they rate this as a 7.6. But if you go to the NIST NVD, the National Vulnerability Database, which is a common source of vulnerability information, you get it as an 8.5. Right? So 7.6 to 8.5, two different scores for the exact same vulnerability. That's another example of that this is essentially subjective and needs to be treated as such. So that's generically an idea to talk a little bit about how vulnerability scanning works in the general case, about how CVEs are assigned or not assigned, and about how CVSS scores are achieved and why you might sometimes get confusing scores. But let's talk a little bit now to focus in on container vulnerability scanning and how this applies to the world of essentially containers. The way that most container vulnerability scanning tools will work is they have two things that they're going to look for. The first is operating system package vulnerabilities. So if your image is based on Debian or Alpine or SUSE or Red Hat, each one of those maintains a security database, which is a list of all the CVEs that apply to packages and which versions they are vulnerable and fixed in. What a vulnerability scanning tool will do is it will open up the image, run the package management tooling to say what are the installed versions of all these packages, and then it will compare that to a downloaded copy of the security database and basically just say, what's the diff here? What's the difference between the installed version and the patched versions? There's your CVEs, and it'll provide you with a list of CVEs. The other thing they'll also do, not all of them will, but most now, is they'll look for programming language packages as well. So if you have a Ruby application, you would have a gem file. If you had a NPM application, you might have package.json, but you'd have somewhere where you list the packages for this application. The tool will do the same idea. It will go and get the security database for that programming language, apply the same logic. What's installed, what is in the latest versions, what are the vulnerabilities in that mix. So there's definitely some things to know about in terms of getting the best out of these tools. The first one is does my vulnerability scanning tool work for my distribution? So the problem here is that I said that they get the package manager, they get the operating system security database. That only works if the tool understands the distribution you're using. So these days they're better, but in the early days there were things like, for example, Amazon Linux. A lot of the vulnerability scanning tools for containers didn't get Amazon Linux support immediately. So if your image is based on a distribution that the tool doesn't handle, then it will just come up null. Another kind of related problem, and this one does crop up quite a bit, is if your image is based on an old version of the distribution, so it's not been getting patched, a lot of the times the tools will fail because there's no security database anymore for that version. So if you're running a super old version of, say, Alpine or Debian, you might get the tool, it won't give you a list, it'll just kind of give you an error message saying, I don't know, because I don't have the security database for that. And you do have to watch for that in your output to make sure that you're actually getting correct results and not just an error message saying I couldn't understand. The other problem you can have with a lot of images is you might be using either Google Distroless or you might be building from scratch images. So you're building like static binaries inside a scratch image. And the problem there is that there is no security database to find. Therefore, they can't do operating system package scanning, nor can they do programming language scanning if you're using static binaries. So if I statically compile a Golang program, put it into a container image, build that image from scratch, at that point, there's nothing a container vulnerability scanning tool can really tell you once it's compiled. And if you're using that kind of approach, it's important to do your vulnerability scanning at the source code level. So scanning the Git repository or some other place where before you compile the artifact in. A similar problem for programming languages is if you're using a programming language whose repositories aren't supported. So say you're using Rust, for example, and the tool you're using doesn't support Rust, then you're obviously going to miss those vulnerabilities. So there is definitely something to watch for when you're choosing a vulnerability scanning tool, is to make sure that the distributions you use and the operating and the programming languages you use are fully supported by that tool. And there is some variance depending on the tool, so it's definitely worth looking into. Another problem, and this is kind of an interesting one for Debian and Ubuntu derived distributions, is what's known as the problem of unfixed. The Debian project and the Ubuntu organization maintain a list of unfixed vulnerabilities. These are things for which there is a CVE, which exists, but for which there is no patched package. And the problem from a vulnerability scanning standpoint is, do you report those? Right? So if I have an unfixable issue, something that even if I apt update to the latest possible version will still exist as a CVE, do I report that? And that can be a tricky problem. Traditional vulnerability scanners, so things like Nessus again, or Nexpose, or Qualys, when they're scanning virtual machines, they will always take the approach that I've seen. They'll say, don't tell anyone about unfixed. Do not mention unfixed. So if you scan a fully up-to-date Debian, you get no issues. The container vulnerability scanning tools I've seen all default to the opposite, and they will tell you about unfixed. That can be quite frustrating, because you essentially have done the best you possibly can without source compiling your packages, and you're being told that you still have vulnerabilities. So most tools, not all of them, will allow you to configure this as an option. So you can actually choose to ignore unfixed or not. The one I'm most familiar with is Aqua's Trivy, and that has a flag called ignore unfixed. Whether you do that or not essentially is down to your own organization's threat model. I would say for most organizations, I probably would turn on ignore unfixed. It's consistent with your scanning that you'll be doing at your virtual machine level, and also, are you really going to source compile your packages? But if you're looking for super high security, then maybe you want to know about that, and maybe you want to try and source compile to make sure you come up with a completely clean vulnerability scan. That's a decision each organization has to make. The last one to mention is about whether the vulnerabilities actually apply to containers. Comes at this point about when people are scoring things, they're scoring a generic use case. They're not scoring container images. This vulnerability, CVE 2019-5021, was in Alpine container images where there was a null password in etc shadow for root, which allowed anyone on a standard VM install to sue to root with no password. A super bad vulnerability, no doubt, and it got given a 9.8, which seems high even for that. But the thing is, most container images already run as root. So this does not apply at all in that case. If you're already root, right, this and any other local privilege escalation just don't apply. You're already the root user inside the container. It makes no difference if someone can escalate to root. And even if you are not running as root, which obviously you shouldn't be, you should not run your container images as root, even in that case, this was only exploitable when Linux PAM software or something which used Linux PAM was in the container image. Most containers do not do that. In fact, I don't think I've ever seen a container image that worked like that. So realistically speaking, in container images, this was probably totally unexploitable in the vast majority of images. But it came out as a 9.8, and if you scanned your images that were built on a vulnerable version, you got this high critical, fix this right now finding. So it's another one where you will find, and specifically things like privilege escalations, they don't really apply that well to container environments. So, to provide a conclusion, the goal of this talk was really to try and demystify container scanning, or to demystify vulnerability scanning, and say, look, it's not some impenetrable process, it's fairly straightforward, vulnerabilities are assigned, the scoring process is then carried out for each one. They're a good starting point, but I wouldn't regard them as canonical. If you think something doesn't feel right about a vulnerability, you're looking at the score and go, that just doesn't look right. You can look into it and find out how was this scored, what were the things the assessment made. You don't know necessarily why they chose something, but you know what they chose. And you can say, well, hang on, that just doesn't apply to my environment. So you should recognize the limitations so you can get the best benefit. Not every vulnerability will have a CVE. Most do, but some don't. So it's not every single time you're going to get a CVE for everything. CVSS scores can be odd. There's no good way around that. Basically, it relies on the analysts on the day when they scored it, and their own personal knowledge and experience of how that software that was vulnerable could be misused. So the scores are never going to be perfect. Two very good practices I think that you should take away from this. One is harden your container images. The fewer packages you have installed inside your container image, the fewer vulnerabilities you're going to have to deal with. It's as simple as that. If you have smaller images, you have fewer vulnerabilities, and that's going to make your life easier if you're trying to think about whether the scores are right or not. If you've only got 5 or 10 to look at, that's not too hard. If you have 5,000, that's obviously not going to happen. The other thing to watch for is scanning tool coverage. Make sure that your chosen scanning tool or tools cover all of the distributions that you are using and cover all of the programming languages that you want to cover. So make sure you get the best benefit and you're actually getting the coverage and the security and control that you think you are. So that is the talk. I think I've got a Q&A box up if anyone has any questions. However, if you do have questions about the talk later on, then please feel free to contact me on Twitter. That's my handle there, which is @Racine, or feel free to drop me an email. You can get me at rory.mccune@aquasec.com. And I'm going to drop off the